won't start doing what it just did a second ago and flickering all over the place. But if it does, we'll see what happens. Before I get going, hands up if we got one of these? Fair few people. How many of you have done this with it? Yeah, that's fair. I'll try and persuade you to get it back out of the drawer with something like this, but we'll see. So this is me. I'm an application architect manager for Avanade. But when I'm not earning money, I go out and I do things like this. Actually, my background is IoT. I've been doing that since 1999, since almost before there was an IoT, making change machines and stuff like that we connected to the internet, but before that even was a thing. I'm also an Azure MVP. There's a few of those hanging around at this conference as well. And I'm organised a few meetups, so .NET Knots, Knots IoT, one called Lati, podcaster, but this is the sort of stuff I enjoy doing, so hopefully you'll see that today. Now, I give this, this is actually the last time I'm going to give this talk at an NDC, because I've given it at all the NDCs now, so there will be no more, so this will be the last one. And we're going to be doing bits like how we get it installed on a Pi, because it's not as simple as you'd hope, but I've solved that. Then we'll be talking a bit about GPIO, and then we'll talk about how we can start flashing LEDs and reading buttons, which is hello world in the IoT land. Then we'll talk about device bindings and driving servos, Blazor and SignalR, and final demos. Now, normally when I go through that, that's okay, but after I did this in Oslo, I got this comment saying that you need to be an embedded SBC god with all these acronyms to be able to understand what that's doing. And actually, there was a second piece of that comment, which I'll alleviate just by going onto this screen. And if you look down here, there's a flashing LED, and that will be our hello world that we'll get to as our first step. But nonetheless, I want people to be happy and understand. So, quiz. What does IoT stand for? Very good. So you don't need to be some embedded god to understand these terms. It is. It's also a swear word. GPIO. Very good. LED. Ah, good. When I did this, by the way, at Porto, there was free beer for everyone that answered questions, but I was told 20 past 10 was early for beer, so I didn't. SDK. Yes. Oh, we've got flashing AV. Hopefully that cures itself quite quickly. PWM, that says. Good. You're good. VGA. Hello. Without that on the screen, we'll get the screen back. SPI, anyone? A little bit more in depth. Oh, close. Serial peripheral interface. Very good. And I unplug this and plug it back in again. That always works. We tried 2 different adapters as well, so I'm pretty sure it's not my laptop. 1 sec. Yeah, I think so. Yeah, should be. That might have been better. Well, at least we had flashing before. Can do. Apologies. Apologies. An IoT talk has to have something that goes wrong. You're just not normally the AV. How odd. We can all crowd around my laptop if you want. Get a whiteboard and draw it on there. It knows it's connected. I should have brought the beer. It's true.
I've seen him do that talk in various places around the world. It's a lovely day. Let's go to that in Portugal. Let's go to the beach. Let's go to the park. And someone in London shouts out park.
Yes.
Never been proud. City. That's the spirit.
One more try. Come on then, you can do it. Right, nobody move. Now I've put my clicker down like this. Right. Yeah, so the other comment at the end of that, by the way, that was 14 minutes later, well, Lisa showed the LED a minute ago before all of that because it's been about 20 minutes now. It wasn't actually in Oslo, it was 11 minutes, so, you know, nonetheless, you got it in a couple of minutes. It's good. .NET 9, you may have seen on the agenda, actually, this was a .NET 8 talk, which it was when I submitted it, and then .NET 9, of course, comes out in October. So it's actually .NET 9. We get a bunch of stuff. Don't listen to me talk about what's new in .NET 9. Go and watch Mads Torgerson's talk. If you weren't here last night, he was talking about some stuff that's even coming in .NET 10. C# 14, actually, he was talking about. But AI building blocks, because, you know, if you're going to do any amount of work, you've got to put AI in it these days. Feature switches, which is quite cool. It used to be that you'd need a separate piece of software to do that. That works out quite nice. Link, and there's some group by and order by stuff now, which is nice. Way faster. I think in some cases you've got like 90-odd% less memory used just by switching to .NET 9, which is quite a vast improvement. JIT improvements, which is nice, and then all of the cool stuff in C# 13. So you can follow that bitly. You don't need to follow all of these. There's a QR code at the end to get the slides, so you can do that. All of this stuff is nice, but actually the part of this that I like is this 40% new to .NET are students. That's slightly older than 2023, that stat. Don't know what the latest version is, but I like that because, of course, if it's in academia, then it's going to be coming up through the ranks into business, which is a good thing to see for .NET. The reason why I'm showing this is that really this is a big lie. This is an underhand way of giving you a talk about .NET everywhere, which you'll see as we go through. Now, it's non-trivial to get .NET on the Pi. Certainly if you're in Linux land, great, and if that's where you live. If dealing with Bash and all of the underlying operating system is not something you do every day, it can be quite complicated. But I've created a single line install script for this. By all means, go and check out what the script does, because you don't want to just install anything on your Pi because of Bitcoin and China. So absolutely do check it out. But what this does, it goes through all of the prerequisites, gets that all installed, you reboot your Pi, and now you've got the full .NET SDK on there to be able to play with. The way I'll be demonstrating this, I'll be working directly on the Pi. I don't recommend you do that in anything approaching production. You can do remote development, remote debugging, remote deploy, all of those sorts of things in a nicer way. But this is the simplest way to show you how you can use .NET on a Pi. So, GPIO, as somebody mentioned, general purpose input output. If we want to do that, you can't do that with plain old vanilla .NET. You're going to need a NuGet package. So the system.device.gpio NuGet package is where you start. And that allows you to do the basic I/O stuff, so flashing LEDs, reading buttons, but also things like serial peripheral interface, pulse width modulation, which is important for our servos and robot arm, and I2C, which is another serial-ish communications method you could use. It actually supports other boards than the Raspberry Pi, but I wouldn't bother. I'd just use the Raspberry Pi. It's a lot easier. And you know, you've got a level of support with that as well. It actually supports Linux, and I leave this Windows 10 IoT on here because some folks come and say, isn't there a specific Windows version for the Pi? And yes, there is, and it's not just the way to get Windows 10 on your Pi. There's a branded Windows 10 IoT to get WPF or XAML on there, but it's been dead for a long time. So please don't think of that as a way forward. If you want to do .NET-driven GUI apps, then use something like Uno Platform, which is brilliant, or you know, Maui maybe. Sadly, it doesn't support the Pi 5 because they went and rearranged the whole architecture on the Pi in the Pi 5, and nobody's had the time, I don't think, to go and upgrade it, sadly. So Pi 4 down for now. I made a pull request so you can do flashing LEDs and reading buttons, which is nice just to show something if you want, but anything past that you can't because it needs re-architecting. Maybe if I retire I could do that, but hey. GPIO on the Pi, that's these pins down the side. And you'll see there's things like ground, and we've got transmit and receive and PWM, and we've got numbers. So you'll see there's BCM numbering, that one there, so BCM 14, 15, 18, and there's board numbering. And this is important because you need to tell .NET which of these two numbering schemes you want to use. For the love of God, don't just do the BCM, don't do it. I don't know why people do. I can count those pins, so just use board numbering. But you'll see that in the code in a bit. If you've done any amount of IoT, then hello world on this is flashing an LED and reading a button. Once you've got that working, you know you've got a level of control over your Pi, and it's a really good way just to make sure you've got everything set up. So that's where we start. I'm assuming a few of you have made circuits like this before. Hands up if you've made a flashing LED in a so most people just do that and stop. Or sometimes they do like a temperature and humidity sensor, which, you know, don't use that as your next example. Cliff loves temperature and humidity. So what your talk's about, isn't it? Yeah, just that, an hour, BCM. No, do cool, interesting stuff like this. Otherwise, you're going to be sitting there breathing on a sensor and watching a graph go up a little bit, and it's not the best use of your time. Make something that's far more interesting than that. So what we've got for Hello World, we've got pin 10 connected to one side of a resistor and up to an LED. And then we've got pin 12 connected to one side of a button and then back down to ground to make that circuit work. No resistor needed for the button. If you know anything about electronics, a button, if you have those two wires, will just be floating if it's not connected to anything. You press that button and it makes the circuit. If you don't press it, it's just floating. So you've got to pull that, as it's called, to a particular level. And inside the Pi, it's got some weak pull-ups that you can activate. That's important. That's in the code. If you don't do that, one day it'll work and one day it won't, and you'll wonder why. So you'll see that in the code, which we can show you now. Please don't break. Is that zoomed in enough for folks to be able to see? So at the top here, we have our NuGet packages, including the device.gpio package that I mentioned earlier. So that's the one that you're going to need to pull in if you want to do any amount of work, and that's what we're going to be using for most of what we're doing here. And then we've got a basic console app. So we start off with Hello World. Now I leave that in there because if you don't, then certainly for the one that I'll show you in a minute where we're reading a button, you've got no idea when it's actually ready. And we're compiling this on the Pi. And the Pis are good, but they're not a desktop machine, so they can take a while to actually run up. And you'll even see that when I'm trying to switch branches. I'm not going to code. I don't do coding in front of people. I'm not Dylan Beattie, brave enough. I mean, it's dangerous, yeah, and boring. So I'll be switching between branches, but it's on the Pi, so it'll take a while. And everything is running through my hotspot on here. And I mean everything. So yeah, things will take a while. Below that, though, we've got this GPIO controller on line 14. And you can see here on the right-hand side that we have got that pin numbering scheme set to board. So important to pass that in, and then you can just count your pins. And then we've got pin 10, which is what we've got connected to our LED. And then we're defining a variable light time and setting that to 300, which I'll come back to. And then we open that pin as an output. So we flash the LED, so we're driving out. So after that, we go in a loop forever, flashing an LED on and off. And we sleep for that 300, which turns out to be milliseconds. What happens if you don't do that? Anybody know? You just get a slightly dim LED. So you've got to have a gap in between there, otherwise you don't see anything. And then just for a bit of safety, we close the pin when we finish. And when we run it, then we get a flashing LED, which if I use that one instead, we can see our flashing LED. There's lights, so it's not all that bright, but you hopefully see that flashing away. So that's good news once you've got to that point, because now we've got some level of control, but we really need an input as well, so we need to read a button. So we stop that code. We can switch. And I'm doing it this way slowly because you just get these concepts right, and then everything else will flow after that. So there'll be a couple of jumps afterwards. This code is almost identical. So at the top, we have our system.device.gpio still. And then further down, we still have hello world on line 12. We still have our GPIO controller. Now we've got a button pin on 26. We still have our LED set to an output. But here we've got our input pull-up. So that we need to make sure we've got that so that that button sits there high. And when you press it, it goes low. Now, it makes the logic a bit backwards, actually, because a 1 is normally on, and a 0 is when you press it, and that's off. So it kind of feels like it's backwards in the logic, which you'll see. So if the button pin, when we read it, is false, 0, you've pressed it, then we set the LED on. So it kind of feels a bit backwards, but once you know why, you can see that. So if we run that, and you see this is why we need the hello world in this case, because it's not ready. And you'll be pressing the button going, my code doesn't work. And you'll spend 20 minutes wondering why, like I did the first time I ever did this. So that's the program running. So the LED is now off. And I'm going to zoom in a little bit down here. And if I press the button, and the LED comes on. And that is the most expensive, complicated way to connect a button to an LED you could possibly do. And very boring, obviously. But nonetheless, what we've done at that point is proven that we can read inputs and drive outputs, which is a pretty important step, because now we've got .NET running, building on our Pi, and we can control peripherals directly with it, which generally, for anybody, that's pretty cool at that point, because now I've made physical things happen, which is why I love IoT. And then most people do temperature humidity after that, and then put it in the drawer, like all you all did. Don't do that. Do something more interesting. So I'm going to stop that code, go back to my slides. There we go. So if you want to do anything much more than that, then again, you're going to need somebody else's code. You could write these things yourself. So if you want to read the temperature from your BME to 80, go ahead, do that if you like. If you want more I/O, because that GPIO is limited, you've only got a certain number of pins, you can actually control via a little device which is driven by SPI or I2C, an I/O expander. So they're pretty good, actually, work quite nicely. With a Pi, you can get these things called hats as well, hardware attached on top. And that gives you a bunch of extra stuff. So the Explorer hat's got a bunch of sensors on it. The Sense hat is actually really cool in that there's a Sense hat and I think now 2 Raspberry Pi 5s on the space station. Tim Peake took 2 Raspberry Pi 4s up there originally. And kids can do something called RaspberryPi every year, and they write science experiments that run on the space station. It's so cool. And geez, if you want to get somebody into programming, tell them it's going to be running in space. I should have been an astronaut, really, obviously, but you know, probably don't have the body for it now. Servos. So somebody has written code for servos and a bunch of other stuff. Now, I mentioned servos a few times. Who knows what a servo is? Few people, good. These things work by pulse width modulation. Now, this is for demonstration purposes. It doesn't look exactly like this, but nonetheless, the concept still stands. The idea is that you send pulses of a certain width and a certain space in between, and you will move the servo in a direction. So if you imagine short pulse with a bigger gap will go one way, you know, a medium pulse with a medium gap will go in the middle, and then a long pulse with a slightly shorter gap will go the other way. Now, if you look at this on an oscilloscope, you'll go, Pete, you were wrong, because those pulse width differences are minute, which is super important, actually, because we've got hardware PWM ports on our Pi, and we can connect up a little board. Now, this little board I've connected up at the top, all it does is separate the power from those control signals, because they actually take a fair amount of current, certainly if you do what's called stalling them. So if you hit them against the very end, or when you first start them up, they draw a fair amount of current. You can actually kill the pins on your Pi. So separate the power from the control signals, which is all this board's doing. You can either buy one of those, it's called a Servo 6 board, or you can just build it. I've built one down here as well. You hook up ground. Now, if you do buy this board, bear in mind that ground is this pin. I read that as channel 1 and wired it up and nothing worked, and that was 20 minutes of scratching my head until I realized that. So first pin's ground, and then on pin 25 on the Pi. And then we've got our control signals for PWM, so that pulse width modulation. Now, it does it in hardware on those 2 pins. So you tell it what frequency to go at, so which position, and the hardware underneath does it for you. However, if you've got 3 servos to drive, like I have here, I've got a rotate, a reach, and a grip. You can do it in software, but you've got to be careful. You can connect it, and then you define it in your code, but you've got to make sure you put it into what's called a high-resolution timer mode, because now we're sitting on top of the operating system trying to do those tiny, teeny little pulses, and it does stupid things and just doesn't work if you don't notice that. And it wasn't particularly obvious either, so it took me ages to figure that out, actually. And it was one of the people that maintained that NuGet package that sent me a message afterwards when I was crying on Twitter. On the other side of this, we plug our servos in. Now, has anybody bought servos and played with them? A few people. You've never done it, have you? You can buy them 10 a penny from Amazon. And the wiring will be something like this. It could be yellow, brown, and red, or those or thereabouts. But you'll have a control, and you'll have a power, and you'll have a ground. And you can't blow these things up if you plug them in the wrong way. But on this board, there's a little C. It's tiny. It's just where my green arrow is, just above that. You'll see there's a little C. And you just get it orientated the right way round. And now we've split the power off and connected our servos to the Pi in a safe way. So let's see what this does. We're actually going to make a dancing robot arm. And again, switch branch. Move our servos. The good thing about the delay is I can drink some water. Don't worry about the red squigglies on this. Changing branches, it doesn't like. But nonetheless. So at the top here, we now have our device.GPIO there on line 2. But we've also got device.pwm, device.pwm drivers, and IoT.device.servo motors. So that device.pwm, that's coming from the IoT NuGet package. So that gives us access to the PWM on the Pi directly. And then servo motor, what that allows us to do is, instead of trying to work with frequencies, which is hard, you just give it an angle, and it then converts that into what it needs to do to get that to work. And it also gives us this software-driven PWM port, which is useful. So scrolling down, we have a PWM channel that we create. Now there's 2 PWM ports that I mentioned earlier on one chip. So that first 0 there, that is the chip. Then the next 0 in that case is the PWM port. 50 is the frequency. So we create a channel, and then we use that channel to create a servo motor in that device's NuGet package. 180 is the total angle we've got, and then 700 and 2400 are the two stops at either end. They're cheap, these servo motors, for a good reason, because they're made in their millions and shipped out, and none of them are the same. So you've got some adjustment there if your end stops aren't quite working or it's doing weird things. That's what those two are for. And we do that again there as well. So we've got a second PWM channel. The only difference is the one there. But then a bit further down, we have our software PWM channel, which actually looks almost identical, only that we define it now as a software PWM channel, and we pass in the pin that we want it to be connected to, pin 27 in this case. And this true on the end is the part that it took me ages to learn, which puts it into high precision mode. So remember to do that because you can do it without. And that makes sure that works. Everything after that, of course, is just a servo motor. You can just pass it in just like any other PWM channel. So now we've got 3 where we only had 2. Then we start our servo motors up. And then at the bottom, I've got a little function that just takes a right angle. It just made it easier so I can pass in the servo and the angle. I didn't need to do that. But nonetheless, we then move to an angle on each of the servos and make our robot arm move. So with a little delay in between. So let's see that working. And I'll move in and out of frame because, you know, you've only got so much frame. And wait. There we go. So that's exercising each of the 3 servos on this. So we've got the grab at the top, which has just moved. Then we've got the rotation in the bottom. And then we've got this reach element. So 3 different parts to a robot arm. Now this is just a robot arm that I got off Thingiverse. I wouldn't recommend you use this one, actually. I've got another one in behind it that guy in front audience, his son redesigned. And it all prints flat. And you just use the screws that come with the servo motors to bind it together and a piece of thread, and you're done. This one, I had to go hunting around in all sorts of places trying to find nuts and bolts that would fit and work, and it was a nightmare, and some of them are metric and some of them are imperial, and yeah, it's cool, but it's a pain. So recommend you probably do that. The files for these are in the repo, so all of this is open source as well. But it's moving. And I could have stopped there and gone, whee, great, I made a robot arm. But I really wanted to be able to move it around myself because, you know, that would be cool. And it gives us some options then at that point. Now, normally, if you think IoT, you're going to be doing things like IoT Hub and stuff like that and using the messaging, but it's not real time. So I wanted real time. So I needed a couple of different technologies to make that work. And the first one I chose was Blazor, because everyone was doing Blazor back then. You could argue Maui over in the corner would be another option. Might come back to that. This is if you've not used Blazor, who's used Blazor? I mean, I'm assuming a fair few have. Yeah, okay, there's a few that haven't. So it's a SPA framework. It was actually developed by this guy, Steve Sanderson, a Brit, and he took it over to a Microsoft conference and demoed it to them, and they went, oh, we need this is the future. One of the reasons is that it gets rid of JavaScript. Now, I've put an asterisk on that because it doesn't, but for the most part, you code in C# rather than in JavaScript. So if you're a .NET house, this is good. Also, you know, if you want to value your sanity, then it's good as well. But, you know, I like React and stuff. Don't get me wrong. There's a load of different flavors of doing this. So you can do it on the server, or you can do WebAssembly on the client, or you can actually do a hybrid approach, which is what I've done here. So if you know that you've got an API backend and you want to do WebAssembly on the front, then you can do it in a hybrid manner. So that's what I've done there. This is plugin-less, so it's not Silverlight, which is good. And supported today in all major browsers, you know, although 5 minutes ago and 5 minutes later, who knows what Apple's doing, but at least today, that should be the theory. Onwards from that, I needed a way to be able to do real-time communications and SignalR. Who's used SignalR? Ah, good. Interesting. What was the first thing you did when you learned SignalR? What did you make? Yeah, of course you did. Now, you'll see my code is based on the tutorial for a chat app, and I did that on purpose because what I wanted all of this to show was we're one step away from a tutorial to drive a robot arm. So there's not that huge leap. So you'll see how this works, and I'll explain that in a bit. If you've not used SignalR, so this is an open source, long-standing real-time communication library using WebSockets and a bunch of other stuff underneath if you need it. Created by these two cool characters, David Fowler and Damien Edwards, in 2011. That's a long time ago, so this thing is well established. Bidirectional real-time comms. As I said, WebSockets, if that doesn't work, it will automatically drop down to server-sent events and long polling down below that. So it will just work in a fashion. And open source, which is cool, so you can go and contribute. Although I don't know what's going to be new now, 13 years later, 14 years later. So let's see how that works and how we can drive the ARM ourselves. So I'm going to flick to the main branch. I'll quickly show you the code for that. This is a bigger change, so it's taken a little while. There we go. Now, the code is pretty much identical. Apart from now, we've got SignalR brought in at the top there. We need that. And we create a hub connection. So all of this is done with a central hub. You communicate through that, and it handles it for you. We've got our PWM channels like we had before. We start them up. And then we have a connection. Which we have defined here. So I'm pointing at where my website is, the other side. Interestingly, don't do this. It says there, dangerous, because I've accepted any certificate. You can also run your Blazor app locally, of course, and if you want your Pi to connect to your machine without having to deal with certificates, then you can do that. Please don't do that in production. Or if you do it in production, could you please tag me? I want to see what happens. So that's good. We've got automatic reconnect on there, and we build the connection. If we stop the app, I stop the servo motors because they make an annoying ticking sound if you just leave them going. So we make sure we do that and then exit correctly to close the connection to the hub. All of this now is a chat app. So we'll see top right-hand corner, we have a user and a message. So, and again, specifically done it this way, where our user is the servo that I want to control, and the message is the angle. And I'll show you the Blazor code in a second as well. So we have 3 different servo motors, servo 1, servo 2, and servo 3. We take that message, parse it into an int, and move the servo. And that's the code. Nothing else to do under those circumstances. We just loop forever. So the Pi code hasn't actually changed that much. We're just receiving that SignalR message, and magic happens under the hood there. I'm going to run it. And while that's running, I'm going to quickly show you the Blazor website. Yeah. So here. Load that. Very good. And then we also get our little video, which will improve in clarity going forwards. But in theory now, we can rotate our arm. And it's wobbly. This isn't supposed to be some professional, I'm not Elon Musk, but he's got humans on the other side of his robot arms just the same as I have, so, and then, so we can control all of the sections of this. Now, that grab is getting a bit old. It's been around the world twice, this robot arm has. So moving it like that seems to work all right, but the gears are a little bit ruined now. But nonetheless, you can see we can now move that, which is pretty cool. Move it around as much as we like. The code on the Blazor side, who's like done Blazor coding at this sort of level rather than just used it randomly? A few people. So you have your HTML markup at the top, and then you have your code at the bottom down here. So that's what all of that is. All at the top we have, as you saw on the screen there, we've got some sliders, and then that video element, which you won't see in here because that's a different branch. When we move those sliders, it's actually going to move the properties of the code behind here. And when that happens, it's going to start sending messages. But also, those messages will be seen back in the interface there as well, so we can receive and send. I'm not going to, burn the ocean going through all of this, but you can get the code online and go through that. But you have a chat hub in the middle. So this is that hub that the Pi is connecting to. It's that. And all it does is send that message out to every other device that's connected at that point. And then if you want to set it up, there's some setup you've got to do to get SignalR in there, but it's not particularly difficult. You can just follow any SignalR tutorial and you'll get that part set up, and then just usurp your chat app into a way to drive a robot arm. Now, I could have stopped there even if I wanted to and said, that's cool, I'm done, I'll go give the talk, but that would have been boring. Once you've got that working, then we can do .NET using Unity for one of these, a MetaQuest 3. Who's got one of these? Cool. Anyone programmed for one? Nobody. Not too hard. Actually, getting the NuGet packages on there is the hardest part, because it doesn't seem to be a very easy way to do that. You have to write your own scripts, because you've got to be targeting an Android operating system, and it's got to be 32-bit, not 64-bit. And if you try and just put a NuGet package in there, it's got dependencies that have got dependencies, and you need to tree all of those, and nightmare. I'm sure you've had those sorts of experiences elsewhere, but nonetheless, that seems to be the hardest part. But Unity's been around for ages as well, since 2002. And we use, I think it's .NET 8 at the moment, or C# 8 rather, standard 2. So relatively up to date, but not brand new. But nonetheless, if you're a .NET programmer, you should be able to do it. I like the fact that it's got support for virtual and mixed reality now as well, which you'll see. And we can build and deploy directly from Visual Studio to the headset and run it, which is a nice pattern. We don't have to build packages and then go installing them randomly and hoping that it works. Quite nice. But yeah, adding NuGet packages is painful. I've got a separate repo because it's a massive repo for this, and you'll find a script in there that shows you how to get the SignalR packages in there. It's about the only thing you'll need. So let's show that, shall we? This bit's fun, I like this bit. I could just stand here and tell you it works, yeah? Because that'd be good. Hold on. But instead, all these virtual desktops, there's many of them. I can cast and you can see what I see. Right. Don't try and tickle me while I'm doing that. Everybody leaves. To the pub, I hope. Right, let me cast this. Bum, bum, bum. Right, you see? See something anyway? Good. You see a robot arm. It's in front of me. It's actually right in front of Dylan's head. I love it because you can wander around your whole robot arm, kill yourself falling off your stages and things like that. The original version of this was just in virtual reality, so everything was blocked out, and people did do silly things at that point. But now, I can see you swearing at me, making rude gestures. But nonetheless, I didn't want to use those controllers either. I wanted to use my hands because I often take this to schools, and getting kids to point at stuff in VR just didn't work very well, but doing it with your hands is cool. So I can pop up my controls directly there, and if everything works according to plan, I can move my robot arm. And not only will it move the real robot arm, but it's moving my virtual robot arm as well, which is pretty cool. And look, see, it's just as wobbly in VR as it is in real life. And move my grab and things like that. Now, what is cool, and I like this because it's actual hooliganism, is that if I go back through enough of these virtual desktops and do this, scan that QR code. I'm going to be mining more Bitcoin, but on your phone now. Very obedient people. Yes, should have done that. And now you can move the robot arm yourself. Now, what I find is that people are hooligans, absolute hooligans. Hey, look at this one. It's ridiculous. It's absolutely ridiculous. But the point we're proving here is once you've got that mechanism set up, then actually you can do some real world applications at this point. Now, please don't do surgery with this robot arm. But the concept is still the same. Obviously, the thing I found when I took this to, look at you, just stop it. The thing I found when I took it to Australia was that this is deployed into Azure in the UK, and latency is a thing. A very real one. So yeah, so that's working. It seems working. What happened in Porto was that when I did this, people left the grab down at 0. So please move the grab from 0, somebody, because it burnt the servo out while I was doing it, and I was then trying to make it work, and it didn't. There you are. Very good. So I'm going to ask you to stop, please. I see you. Hey. Because I have a bonus section. As I mentioned about .NET, you've got to have some form of AI in this. Now, I am not going to do OpenAI on this, please move the arm. However, what we can do, and again, many, many virtual desktops. You're going far enough. And I have a Maui app, just to make my friend over there happy. Start that up. If I leave it running, my laptop's just doing too much, so that's why I have to run it up, but it's quite quick. Hey! I'll trace the IP. Right. And what we have here is a desktop application, but you can also deploy this to Mac, or you can deploy it to your phone or whatever you like, because it's Maui, so deploy that anywhere. Very similar to what you saw on the web, because, Blazor and Maui are kind of similar, but Maui's in XAML. But on the left here, I'm using the speech API because AI, yeah? So, in theory, reach by -20. I can control it with my voice, which I like. It's practically useless, especially if anybody even comes close and breathes, it can't get it out. Let's try. Rotate by 100.
Sorry, I can't move by as much as 100 degrees.
Oh, well, okay. Rotate by 20. I see. Rotate, maybe it's my accent, I don't know. But nonetheless, this is the Speech API and Speech Studio up there in Azure, branch of cognitive services. So we're not talking OpenAI, as I said. But I have seen people do some cool stuff with OpenAI. There's a guy on TikTok that I follow, and he shoots cats with, not real cats, pictures of cats on a screen that move around, and balloons and stuff like that, and he can tell it to switch colours, and it's actually pretty cool. I want to get the guy speaking at my event. But that's the sort of stuff you can do onwards. Once you've started doing this, then you've opened up all sorts of stuff. Of course, as I say, you can run it on your phone as well if you want. This one. And go back a screen. Hello. Oh, too many virtual desktops. And I'm not going to project my phone because I'm nowhere near as good as that. But look, that's the same thing. I can move it around with a mobile app just the same. Which is the reason why I said that this was kind of underhanded, this talk, because really it was a way of telling you that you can use .NET on all of these devices. So we've got IoT, web, cloud, desktop, mobile, gaming, and AI, and I've covered every single one of those in this talk, which I like. The AI one, tenuous, but nonetheless, it is there. So that's it. My cat, sadly deceased, poor cat, used to love it when I was playing with this. For some reason, she loved servos. Yeah, if you don't get things right, it can be very rickety. So much so that, if you're not really careful and you start getting really excited with it, then things will just fall apart. But, it's funny, people come and see these talks and think, oh, that's really cool, I'll never be able to do that. Actually, what I'm trying to show you is that you actually can, and you can make mistakes along the way, and, it's not too bad. Now, that link there will take you to the GitHub workshop at the top. So there's a whole thing here that lets you do that. So by all means, grab that if you wanted to. and then all these other bits. So I've got a blog post now on how to get .NET 9 installed and start playing with LEDs and buttons, and then links to older blog posts, because really this is a lie. We don't need .NET 9 to do this. You can do it all the way back down to 3.5 if you want. It's fine. It will work. Nothing I've done there, as you've attested to yourself, is particularly complicated. NuGet packages, that's the 3D printed robot arm for the presentation. That is the 3D printed robot arm underneath it. And by the way, this is an ESP32, and I can sort of put it underneath there, but the camera's not on. You can run .NET on an ESP32, so tiny little embedded device. Jose Samoes and a team of people have made an implementation of .NET for that tiny little ESP32. It's really good, what they've done. It's not super performant for things like SignalR, I've found. So I don't tend to turn it on very much because it just sits there doing this for ages and, you know, trying to catch up 20 minutes later. But nonetheless, you can do that for proper IoT stuff, and it's good. And I know there's another method of doing this with something called the Meadow. Has anybody heard of that? So, you know, Meadow on there. So that's full .NET, really performant, dual processor implementation, really cool stuff. More expensive, more hard to get hold of than an ESP32 that you can get, you know, 600 for 12p. But nonetheless, no two are the same for that as well. If you want to get in touch, that's the slides. There will be a QR code for the slides, so don't worry about that. Twitter, X, whatever. Blue Sky, actually, I should put on there now. Same Pete codes. You'll find me on Blue Sky. By all means, contact me on there, send me a DM or whatever. My website as well, go ahead and check that out. This is from the Microsoft folks, so there's a Microsoft stand here as well. Go visit them, and you can organise like private meetings with them if there's specific technology questions. You'll probably find a few MVPs hanging around there that can answer questions too. I will likely be around at some point. And I mean, what's the worst that can happen? Magic Smoke may get released. But you've burnt 30 quid's worth of Raspberry Pi, so it's not the end of the world when that happens. And yeah, and that's the slides, and that's me. Thank you very much.